Welcome to Summarize Science. Today, we're looking at how we can teach AI to understand video not just as a series of pictures, but as a window into a real 3D world. Researchers are proposing a new paradigm called supersensing. Think about it. When you watch a video of a room tour, you're building a mental map of the space. Current AIs don't really do this. They're good at naming objects, but they struggle with spatial relationships and remembering things over long periods. In fact, the researchers show that many existing AI tests for video understanding are flawed. Often, an AI can answer questions correctly just by reading text captions of the video frames without truly seeing anything. To fix this, they created a much harder benchmark called VSI Super. One task is like a needle in a haystack challenge, where the AI has to watch an hours-long video and recall the exact locations where a random object briefly appeared. Another task involves continual counting, like keeping a running tally of all the chairs seen during a walkthrough of a massive, multi-room building. These are things humans find intuitive, but they're incredibly difficult for machines that just process frames one by one. To tackle this, they first tried the current approach. They built a powerful new AI called Cambrian-S, training it on a huge, specially curated dataset focused on spatial information. On existing, standard benchmarks, Cambrian-S performed exceptionally well, even beating top proprietary models. But here's the crucial finding. When faced with their new, much harder benchmark, even Cambrian-S and powerful models like Google's Gemini failed dramatically. The model's predicted counts would just flatline, showing they weren't actually counting, but just guessing based on their training data. This proved that simply scaling up data and model size is not the path to true spatial intelligence. This led the researchers to a new idea inspired by the human brain: predictive sensing. Instead of just passively watching, the AI actively tries to predict the very next frame of the video. When the actual frame is different from its prediction, it generates a surprise signal. This surprise is the key. A high surprise score tells the AI that something unexpected and important has just happened, like a new object appearing or entering a new room. The AI then uses this signal to decide what's important enough to store in its memory. It also uses surprise to segment the video into meaningful events, just like chapters in a book. This allows it to break down a huge, continuous task like counting chairs into smaller, manageable chunks, room by room. The results of this new approach were stunning. The surprise-driven AI could maintain its performance on videos hours long, while other models would run out of memory or their accuracy would plummet. Its counting ability also scaled much more realistically, avoiding the flatlining problem seen in other AIs. It wasn't perfect, but it showed genuine generalization instead of just memorization. So let's recap the key points. Current AI video understanding is shallow and can't be fixed just by adding more data. A new approach where AI learns from surprise by predicting the future allows it to selectively remember what's important and structure its experience. This is a big step towards creating AIs that can build internal world models, much like we do. In the future, this could lead to smarter robots that can navigate and remember their environment, or security systems that can truly understand the events of a day. Thanks for watching Summarize Science.